Math 3, Unit 3, Complex Numbers. The biggest thing with complex numbers, and we've touched on this already as a review from Math 2, is the square root of -1 is equal to I. We're looking at a whole new number system, and I squared equals -1. So if you can remember those two things, then you can make this work. When you're simplifying a radical, you're going to simplify the radical the same way you normally would. The only difference is when there's a negative under the square root, you have to pull an I out. So here, this is equivalent to the square root of -1 times the square root of 8. The square root of -1 is I, and then I still need to simplify my square root of 8. So I'm going to do like I would with any other square root. I'm going to list my factors, 1 and 8, 2 and 4. My perfect squares, if you'll remember your perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225, and it goes on, but we stop there for now with our memorizing. So my biggest perfect square factor is going to be 4. So that means that this is the same thing as the square root of 4 times the square root of 2. Just bring down my I. So I have I times 2 root 2, which is 2I root 2. The next one, I have a square root of -49, so I'm splitting that up. Square root of -1 times the square root of 49. 49 is a perfect square, and its square root is 7. Square root of -1 is I, so my answer is just 7I. Square root of -48, doing the same thing, splitting it up. Square root of -1, square root of 48. We have I times factors of 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. My biggest perfect square factor, not just a perfect square factor, but my biggest one is 16. So I have the square root of 16 times the square root of 3, which is 4 root 3. Don't forget about your I. So your answer is 4I root 3. Adding complex numbers, you're going to do it just as if it were a binomial. Treat I as a variable. You just combine your like terms and leave I alone, really. So 5 minus 2 is 3, and 7I plus 6I is 13I. The next one, the only difference in adding and subtracting is I have to distribute my negative. So I'm subtracting 2 and subtracting 4I. 8 minus 2 is 6. 3I minus 4I is -I. The last one, I have 7 minus 3 minus 2I. The only thing I can combine there is my 7 minus 3, so I have 4 minus 2I. When you're multiplying, though, typically you will have an I squared in there somewhere. So you're going to multiply like you would if it were a binomial, but then at the end, combine your like terms and convert your I squared to -1. So here I have 5 times -4, which is -20, and I times I, which is I squared. Always convert your I squared to -1. Don't leave it as I squared. You will not get full credit. So your answer is +20. The next one I have to FOIL out. 6 times 4 is 24. 6 times -3I is -18I. -5 times 4 is -20I. And -5I times -3I is 15I squared. So I'm going to combine my like terms. I have 24 minus 38I and convert my I squared to a -1. So I have 24 minus 38I minus 15. Combine my last set of like terms, and I have 9 minus 38I. Same thing on the next one. 4 times 4 is 16. 4 times 3I is 12I. -9I times 4 is -36I. And -9I times 3I is -27I squared. Combine your like terms and change your I squared. You have 16 minus 24I minus 27 times -1. Simplify that. 16 minus 24I plus 27. And then combine those like terms, and you have 43 minus 24I. Solving with imaginaries or complex numbers. I'm going to subtract 100 from both sides, just like I would normally. I have 4x squared equals negative 100. Divide both sides by 4. You have x squared equals negative 25. Anytime you take the square root, when you're solving, you have the positive and negative. The square root of 25 is 5. The square root of negative 1. This equals the square root of 25 times the square root of negative 1. So you have 5i. So x equals plus and minus 5i. Without the plus and minus, you will not receive full credit. Subtract your 48 from both sides on the next one. 3x squared equals negative 48. Divide both sides by 3. X squared equals negative 16. Take the square root. Remember, you always have to have the positive and negative, and this is equal to the square root of 16 times the square root of negative 1, or 4i. If it's not a perfect square, you will simplify just as we did the ones above. The last one, 150. Negative 5x squared equals 150. Divide both sides by negative 5, and you have x squared equals negative 30. Listing my factors of 30 for when I'm taking the square root here. I have 1 and 30, 2 and 15, 4 doesn't go, 3 and 10, sorry, 4 doesn't go, and 5 and 6. None of those besides 1 are perfect squares. So we can't simplify our radical. The only thing we can simplify is the negative. You have to take that negative out and make it an I to receive full credit. On the back, we're going to graph. Graphing is super easy. It's just a different type of grid, really, because our x-axis becomes our real axis, and our y-axis becomes our complex axis. So they're always written in A plus BI, where A is your real, and BI is your complex. So we're going on the real axis, positive 3, and on the complex axis, positive 2. Well, that is our graph. 14, we're going on our real axis, negative 2, and our complex axis, negative 3. And that's your graph. Not super difficult. The conjugate. With the conjugate, you have to negate the complex part. So what you're doing is changing the complex part, and this will make sense why we do it when we find zeros. Excuse me. But my complex conjugate of 3i is going to be negative 3i. You're only going to negate the complex part, so the bi, not the a part. We have 1 plus I, so my complex conjugate is 1 minus I. This one I'm negating, so I'm changing the sign. I have positive 7i. And then the last one, I'll have 3 plus 2i.